Hello everyone, we're going to continue chapter 5 for project management class. This is called the book we're using, Project Management, the Managerial Process. Is owned by McGraw-Hill, okay, in terms of copyright. Where we are on the chapter 5, it will be based on estimates, okay? There are quite a number of learning objectives for this chapter from 1 to 7. Okay, let's look at one by one. Understanding the project times and costs and its foundation for project planning and control. Number 2, describe the guidelines estimating time, cost, and resources. Number 3, describe the method, uses, and advantages and disadvantages of top-down and bottom-up estimating methods. Number 4, distinguish the different kind of costs associated with a project. Number 5, suggest a scheme for developing an estimating database for future projects. Number 6, understanding the challenge of estimating mega projects and describe steps that lead to better informed decisions. Number 7, define a white elephant in project management and provide example. Number 5, let's look at the chapter outline, okay? Number 1 to 9, factors influencing the quality of estimates. Number 2, estimate the guidelines for time, cost, and resources. Number 3, the top-down versus bottom-up estimation. Number 4, method estimating project time and cost. Number 5, level of detail. Number 6, type of cost. Number 7 is refining estimate. Number 8, creating a database for estimation. Number 9 is mega projects such as special case. Project estimation. Estimate defined is the process of forecasting or approximating the time and cost of completing project deliverables. Okay, it's a trade-off balancing the benefit of better accuracy against the cost of the secured increase of accuracy. And time estimate, a top-down macro estimate, which is analogy, group consensus, or mathematical relationship. Bottom-up micro estimate based on estimate of elements found in work breakdown structures. Why estimating time and cost is important? There's about 6 of them. Estimates are needed to support good decisions. Estimates are needed to schedule the work. Estimates are needed to determine how long the project should take and its cost. Estimates are needed to determine whether the project is worth doing. Estimates are needed to determine cash flow needs. Estimates are needed to determine how well the project is progressing. Planning horizons. Okay, factors influencing the quality of the planning horizons, project complexity, people, project structure and negotiation, planning estimate, and project culture and other factors. Number 2, estimate the guideline for time, cost, and resources. The responsibility, number 1. Number 2, the use of several people to estimate. Number 3, normal conditions. Number 4, time units. Number 5, independence. Number 6, contingency. Number 7 is risk assessment. The top-down, number 5.3, top-down versus bottom-up estimate. This is the most common approach in estimating costs. The top-down estimates are usually derived from someone who uses experience or the information to determine the project duration and total cost. Are sometimes made by top managers who have very little knowledge of the components activity used to complete the project. Bottom-up estimate can take the place after the project has been defined in detail, can serve as a check on cost elements in WBS by rolling up the work package and associated cost accounts to major deliverables, to provide the customer with the opportunity to compare the low-cost, efficient method as well. Let me just go back, just by accident. Provide the customer with the opportunity to compare the low-cost and efficient method approach with the imposed restrictions. In terms of top-down and bottom-up cost estimate, this is the top-down estimate. There's a strategy decision making here, high uncertainty, internal small project here, a stable scope. Okay, for the bottom-up cost estimate, the cost and time important, fixed price contract, and customer wants detail. Okay, make rough top-down estimate. The flow of the WBS OBS, make a bottom estimate, the flow of schedule and budget, reconcile difference with top-down and bottom-up estimates. Top-down approach in 5.4, taking project time and cost, consensus method, ratio method, apportion method, function point methods for software and system projects, and that's learning curves as well. For bottom-up approach, we call it template method, parametric procedure applied to specific task method, and range estimation. Let's look at the apportion method for allocating. For example, total project cost 500,000, 20 for design, 30 for program, 40 for test, document 5%, produce CD 5%. So it's all detailed here. Okay, and this is apportion method. Basic function point process. Example, complexity, number of inputs, outputs, inquiry, files interface from low, average to high, and total here. Example, function of the point count method, which is 15 for input, 5 for output, okay, 10 for inquiries, 10 for files, 20 for interface. So you're going to put here input 15 times 2, low, which is 30, output 5 times 6, 30 is coming from here. Inquiries 10 times 4 coming from here, and 40 files 30 times 12 here, and interface 20 times 10 here, total here. Okay, this is a function point cost system. Estimating system. This is based on estimate as well. Wide, low estimate, average estimate, high estimate, and range here. Hybrid phase estimation from phase 1 to 5 from the need, specification, design, produce, and deliver. You have a macro estimate is number 1. Number 2, detail and macro estimate. Number 3 is estimate, detail, and macro estimate here, produce. And then here, estimate number 4, design will be estimate, detail, produce, macro estimate. And then number 5, estimate here, detail is estimate. So this is hybrid phase of estimations. In the top-down approach versus bottom-up estimate, there's two different approaches. Okay, so let's look at the top-down first. Intended use such as feasibility, rough time, cost estimate, fund requirements, and resource scarcity planning. In terms of preparation cost, 1/10 to 3/10 of a percent of total project cost. Accuracy, minus 20%, and then to plus 60%. Method, various methods, consensus, ratio, portion, function, points, learning curve. Bottom up will be budgeting, scheduling, resource requirement, fund timing. Preparation cost will get 3/10 of a percent to 1%. Project cost, minus 10% plus 30%. Method with template, parametric packages, and range estimates. Level of detail. NWS vary with complexity of the project, need for control, project size, cost and duration, and other factors. Excessive detail. Emphasize the department outcome rather than deliberate outcome. Create more productive paperwork. Inadequate detail. Falls short of meeting the structure's needs. Types of cost. Direct costs such as clearly chargeable to specific work package, such as estimate labor, materials, equipment, and others. Direct costs can be tied to project use such as workplace. Salaries of project manager, temporary rental place, and project team, suppliers, space machinery. G&A, overhead costs, are not directly linked to a specific project. Example, advertising, accounting salary, and senior management above the project level. Direct costs, 80,000. Example here. Overhead, 20,000. Total direct cost is 100,000. G&A overhead is 20%. Total cost 120,000. Profit 124,000. Total bill 144,000. Three views of cost. Committed here. This is the actual cost. Schedule budget. This is schedule. The actual cost is this one. Committed is this one. Okay? So see the difference. Terms of project duration. In refining estimate, there's a reason for an estimate. Interaction costs are hidden estimate. Normal conditions do not apply. Things can go wrong on project. Project scope and plan change. People are overly optimistic. People can engage in strategic misrepresentations. 5.9, creating database for estimations. Estimating database all the way from documentation, risk analysis, operation processes, MIS, hardware, productions, programming. Example here, estimated actual of labor, materials, equipment, benchmarking, as well as code of account. 5.9, project, mega project, special cost. Example here, mega project define a large-scale complex features that typically cost $1 billion or more, take many years to complete, and involve multiple private or public stakeholders. Example, how high-speed rail lines, airport, healthcare reform, the Olympics, develop new aircraft. Often involve a double whammy. Project costs are much more than expected and under-deliver on the benefit the project were to provide. A summary referred to as a white elephant. Projects are over budget and undervalued, and the costs are maintaining the project exceed the benefits reserved. In RCF, which is reference class forecasting, three major steps. Select a reference class of a project similar to your potential project. Number 2, collect and arrange outcome data as distribution. Create a distribution of cost overrun as a potential of the original project estimate. Use receiving data to arrive at the realistic forecast. Compare to original cost estimate for the project with reference cost project benefits such as outside medical data, political, static, and promotional forces have difficulty ignoring outside RCF information. RCF stands for reference class forecasting. Okay, RCF serves as reality check for funding large project. RCF helps executive avoids unsound optimism. RCF leads to improve accountability. RCF provides a basis for project contingency plan. This is the key term for this particular chapter. Apportionment, bottom-up estimate, Delphi method, direct cost, function points, learning curve, overhead cost, base estimating, range estimating, ratio method, RCF, reference cost forecasting, template method, time and cost database, top-down estimate, and whatnot. Alright, that basically concludes this chapter. I'll post it in YouTube as well as Edpuzzle for your interactive learning. Thank you. Bye-bye.